In this video, we are going to focus on how we can come up with the final outputs of logic gate circuits. Okay, so let's draw the first question. So how can we do this question? Well, here we can clearly see there are multiple gates used. But what we have to do is you just have to go through the signals. That's it. So if you see here we have A, and A is passing through this AND gate, and there is B coming to this gate. So the output will be A dot B. Okay, and similarly here we have A. A is passed through a NOT gate. So you have A bar, and this is B, so the output will be A bar plus B. And then this B is moving through a NOT gate. You can see that clearly. So this will be B bar. Okay, so since this is A dot B and this is A bar plus B, the output will be A dot B dot A bar plus B. Yeah, you can see that, right? This is an AND gate. So that's how it works. So here we have B bar. So the output Q will be equals to B bar plus A dot B into A bar plus B. That's it. So what did we do here? So let me revise the steps. First of all, you will move along the signals. Okay, you will move along the signals. Okay, you will move along the signals. Then we will reach some gates. So we have to find out the output of those gates. Okay, so sub gates. Okay, and once we are done with all the sub gates, we will have the solution. Okay, so this is what I would like to call the 3S method. Okay, so follow along the signals, find the outputs of the sub gates, finally get the solution. Okay, so I hope you understood this specific question. How can we do this question? We will follow the signals first. So we have A here, so this will also be A. Here we have B here, so this is B. So since this is an OR gate, the output will be A plus B. Okay, and then here we have A again. So here also we have A. Here we have B. So here also we have B. What will be the output of NAND gate? You remember NAND gate? Well, that will be A dot B whole thing bar. Okay, so since we have A plus B here and A dot B whole thing bar here, the output of AND gate will be A plus B into A dot B whole thing bar. And finally, we are sending this whole output through a NOT gate. So what will Q be equals to? It will be A plus B into A into B whole thing bar. Okay, so this is what happens when we do this question. Okay, always remember the method: signal, subgates, finally the solution. How are we going to do this question? Well, straightforward. Here we have A, here we have B. So the output of NAND gate will be A dot B whole thing bar. Here we have B, and this is B bar. Why? It is passed through a NOT gate. Now we have A dot B whole thing bar here, B bar here. So what will be the output here? It will be A dot B whole thing bar dot B bar. Okay, and here we have B bar, and this is a XOR gate. Okay, this is and I think it's AND because we say X. So this is an XOR gate. Okay, so what will be the output of XOR gate? Well, let's revise it. So if you have an XOR gate and you are passing through two outputs such as A and B, the output can be given as A XOR B. Okay, and A XOR B can be written down as A B bar plus A bar B. Okay, so first of all, we will just write using XOR and then we will expand it. Okay, so what will Q be equals to? Well, we have A dot B whole thing bar into B bar, and here we have B bar. So it can be given as A dot B whole thing bar into B bar plus XOR B bar. Okay, Now we can rewrite it. Okay, we can expand and rewrite it in this format. So first of all, we have to write a dot b whole thing bar into b bar into b bar bar. Why? Since here we have already have a bar, we have to put another bar. Okay, because consider it like this. Okay, let's say q is given as, since we have q as a dot b whole thing bar dot b bar XOR b bar. That's what we have. Ilaya. So we can consider this as a single term and we can consider this as a single term. Okay, won't you agree with me? Let's say this is equals to x. So x can be given as a dot b whole thing bar into b bar, and y can be given as b bar. Okay, y can be given as b bar. So this can be given as x XOR y. If something is x XOR y, the output is x y bar plus x bar y. Okay, so what is x here? X is this guy, and what is y bar here? Since y is b bar, y bar will be b double bar. Okay, or we can say b double complement. Okay, and then plus we have to have x bar, so which means we are going to cover all this with a bar. So a dot b whole thing bar into b bar whole thing bar into b bar. That's it. Okay, very straightforward. Yeah, so this is how you should be able to do different types of questions. Now let's do an easy one. How can we do this question? Well, let's follow the signals first. Here we have A, here we have B. So the output will be A dot B. Okay, and then here we have C, and this guy is B. So the output will be B dot C. Okay, and A dot B pass through NOT gate will give us A dot B whole thing bar, which is exactly equals to one gate. Okay, so instead of using two gates here, we can use a single gate. Okay, but that's not important here, right? That's not important here. So let's continue. Here we have B dot C. Okay, here we have B dot C. Here we have A dot B whole thing bar. So the output will be, or can be given as A dot B whole thing bar plus B dot C. Okay, so that will be the output of this OR gate. Here we already have A dot B whole thing bar. So this is a NAND gate. So the output will be, let's say this is equals to Q. So Q will be equals to A dot B whole thing bar dot A dot B whole thing bar plus B dot C whole thing bar whole thing bar. Okay, so this is, let's say this is x, let's say this is y, so then output will be x dot y whole thing bar. That's what NAND gates do. Okay, so this is x and this is y and this is whole thing bar. Okay, and this is how you have to do this specific question. Now let's focus on another question. In this question, we are going to find z. Okay, so what is the way that we do? First of all, let's follow the signals. So here we have A, here we have B, here we have A again, here we have C, here we have B, here we have C. So this will be A dot B, and this will be A dot C, and this will be B dot C. So the output can be given as A dot B into A dot C into B dot C. Okay. Well, if this was an AND gate, it will be correct. Since this is OR gate, we have to put plus here. Okay, we have to put plus here. Please be careful about that. We will make careless mistakes, so please make sure you don't make them. Okay. Now let's do another question. Now we are going to find out what f is. Okay, so we have B here, we have C here. B and C will give us B dot C, and this will give us, well, A is directly going here, and this is not K, which means the output is B dot C whole thing bar. So the output will be A plus B dot C whole thing bar. I know today the questions were not exactly increasing in difficulty, but it's not what I wanted to do. I just want to make you familiar with these things. Okay, so they won't actually ask you to find the output of the circuit. Okay, they just normally they will ask you with the truth table. But why am I doing this? Because it's very basic. Yeah, it's very basic, and it's the foundation for you to draw things. Okay, it's the foundation for you to draw circuits. Okay, for example, if they give you the output, let's say they give you the output f is equals to a plus b dot c whole thing bar. What you have to think is, this looks complex. Obviously, this looks complex, but what you have to think is, how can we achieve this specific expression by using gates? Okay, that's what you have to think. That's why I did these small examples. What I want you to do this, okay, sorry, what I want you to do for today's lesson is make some random circuits by yourself, okay, by using all the gates that we have studied, the basic gates and or not, and then the advanced gates NAND, NOR, and XOR, XNOR. Okay, use them, okay, and then find the expression. Okay, once you do this multiple times, you will be able to draw by yourself. And that's what we are going to look at in tomorrow's video. Okay, so definitely stay tuned.
Thanks for watching the 5th video in our Logic Gates series. If you found this deep dive into finding the output of logic circuits helpful, don't forget to like, share and subscribe for more lessons. Hit the bell icon to stay updated with our latest videos, check out the full playlist to master Logic Gates, and follow us on Instagram. I'll see you in the next video. Until then, keep learning and stay curious. Bye bye.